Hey everyone, welcome back to the Cosmic Spectrum, your go-to source for all things space and science. Today, we're diving into one of the most intriguing mysteries of the universe, the Fermi Paradox. Named after physicist Enrico Fermi, the paradox highlights the apparent contradiction between the vastness of the universe and the lack of any observable evidence for extraterrestrial civilizations. Consider this, our galaxy alone contains hundreds of billions of stars, and there are billions upon billions of galaxies in the observable universe. Even if a tiny fraction of those stars harbor planets, and a smaller fraction of those planets support life, the sheer scale of the cosmos suggests that life beyond Earth should be a statistical certainty. So, why the deafening silence? Where is everyone? We'll explore 10 current theories that attempt to explain this cosmic conundrum. Our first theory is the rare Earth hypothesis. This idea suggests that the conditions required for life, especially complex life, are incredibly rare. Earth might be a unique oasis in a largely barren universe. Life requires a remarkably specific set of circumstances to arise and flourish. We need a star like our Sun, providing a steady stream of energy, a planet in the habitable zone where temperatures are just right for liquid water. Our planet boasts a protective magnetic field, shielding us from harmful solar radiation. The rare Earth hypothesis argues that this confluence of factors might be exceedingly uncommon. It's a humbling thought, to consider that our pale blue dot might be a singular beacon of life. Could we be truly alone? Let's move on to our next theory. Next up is the Great Filter Theory, a sobering concept suggesting there's a stage in life's development that's extremely difficult to surpass. This filter could be in our past, making intelligent life rare, or it could lie ahead, suggesting advanced civilizations face obstacles preventing interstellar communication. Imagine the journey from primordial soup to a spacefaring civilization as a challenging obstacle course. The Great Filter could be any number of hurdles, from self-replicating life to overcoming self-destructive tendencies. If the Great Filter is behind us, we represent a remarkable triumph against the odds. But what if the greatest challenges lie ahead? The self-destruction theory argues that technologically advanced civilizations tend to self-destruct through nuclear war, environmental collapse, or other means before they can spread throughout the galaxy. This suggests that the very advancements that make a civilization capable of interstellar communication might also lead to its downfall. It's a chilling thought that the same ingenuity that allows us to harness the power of the atom, to manipulate the building blocks of life to create artificial intelligence, might also sow the seeds of our own demise. Perhaps there's a dark irony woven into the fabric of intelligence itself. As civilizations advance, they develop ever more powerful technologies, but those technologies often come with inherent risks. The ability to manipulate energy on a massive scale brings the threat of devastating weapons. The drive to expand and consume resources can lead to environmental degradation and collapse. Even the pursuit of artificial intelligence, while holding immense promise, could result in unintended consequences that threaten our very existence. The self-destruction theory posits that this inherent tension between technological advancement and self-preservation might be a universal constant. Civilizations rise, they innovate, they push the boundaries of what's possible, but in doing so, they often create the very tools that lead to their downfall. It's a sobering reminder that progress is not always linear, and that the pursuit of knowledge and power must be tempered with wisdom and foresight. Fourth on our list is the natural catastrophes theory. This idea proposes that civilizations may be wiped out by natural events like supervolcanoes, asteroid impacts, or nearby supernovae before they can establish interstellar communication or travel. The universe, for all its beauty and wonder, can be a chaotic and unforgiving place. Earth itself bears the scars of countless cataclysmic events throughout its history, from asteroid impacts that wiped out the dinosaurs to massive volcanic eruptions that plunged the planet into darkness. The natural catastrophes theory suggests that these events might be a regular occurrence throughout the cosmos, snuffing out life on a cosmic scale. Imagine a civilization on the cusp of achieving interstellar travel, only to be obliterated by a gamma-ray burst from a distant star, or a rogue planet flung from its system, colliding with their homeworld. It's a stark reminder that we are at the mercy of forces far greater than ourselves, that even the most advanced civilizations might be powerless in the face of the universe's awesome and unpredictable power. Then we have the inhospitable universe theory. This theory proposes that the universe might be more hostile to life than we understand, with cosmic radiation, gamma-ray bursts, or other factors making the survival of advanced civilizations unlikely. The conditions that allow life to thrive could be far less common than we hope. We often view the universe through the lens of our own existence, assuming that the conditions that allowed life to flourish on Earth must be commonplace. But what if we're the exception, not the rule? What if the universe, at its most fundamental level, is indifferent or even hostile to life? Consider the vast distances between stars, the harsh radiation that permeates interstellar space, the destructive power of supernova and black holes. These are not merely abstract concepts, but very real threats to the long-term survival of any civilization, no matter how advanced. The inhospitable universe theory suggests that the challenges of interstellar travel might be insurmountable, that the distances are too vast, the dangers too great, and the resources too scarce to allow for the widespread colonization or communication between star systems. Next is the technological singularity theory. According to this hypothesis, civilizations may reach a point of technological singularity, after which they lose interest in physical expansion or communication. They might focus inward on virtual realities or other pursuits, effectively isolating themselves from the rest of the universe. Imagine a civilization that has reached a point where technology has advanced to the point of near omnipotence. They have solved the mysteries of the universe, conquered disease and aging, and created virtual realities so immersive and compelling that they surpass the physical world in every way. The technological singularity theory suggests that such a civilization might lose interest in the mundane concerns of the physical universe. Why bother with the vastness of space, the challenges of interstellar travel, or the search for other life forms when they have created a perfect, self-contained existence within their own technological utopia? In this scenario, the silence of the universe is not a sign of absence but a sign of transcendence. Advanced civilizations might be out there, but they are no longer bound by the limitations of their physical forms or the constraints of the material world. They have moved on to a higher plane of existence, leaving us behind in their cosmic dust. Isolation by choice is another interesting theory. It suggests that advanced civilizations may intentionally avoid contact with others to avoid potential risks, such as cultural contamination or hostile encounters. They might be aware of us but choose to stay hidden. Imagine a galactic community of advanced civilizations bound by a strict code of non-interference. They have learned from the mistakes of their past, from the dangers of unchecked expansion and the potential for conflict between vastly different cultures. The isolation by choice theory suggests that these civilizations might observe younger, less developed species like our own from a distance, waiting for us to reach a certain level of maturity before initiating contact. They might be waiting for us to outgrow our self-destructive tendencies, to embrace a more sustainable way of living, or to achieve a level of technological sophistication that would allow us to join their galactic society as equals. It's a tantalizing thought that we might be living in a cosmic neighborhood, surrounded by unseen neighbors who are watching and waiting for us to prove ourselves worthy of joining their ranks. The eighth theory is undetectable communication. Alien civilizations might use communication methods that we cannot detect, such as neutrino beams, gravitational waves, or other advanced technologies beyond our current understanding. This means we could be missing their signals entirely. Our current methods of searching for extraterrestrial intelligence rely on detecting radio waves or other electromagnetic signals. But what if advanced civilizations have moved beyond these crude forms of communication? What if they are using technologies that exploit the very fabric of space-time, sending messages through the cosmos at the speed of thought? We might be like ants crawling on the forest floor, oblivious to the intricate network of communication taking place in the trees above us. The undetectable communication theory suggests that the universe might be teeming with alien chatter, a symphony of cosmic conversation that we are simply not equipped to hear. It's a humbling reminder of how much we don't know, how much is left to discover, and how limited our current understanding of the universe truly is. Ninth on our list is the zoo hypothesis. Earth might be intentionally isolated from contact by more advanced civilizations, similar to a wildlife preserve. This would allow for natural development without interference, making us the unwitting subjects of observation. Imagine a galactic agreement to preserve certain planets as untouched sanctuaries, places where life can evolve and flourish without outside interference. The Zoo hypothesis suggests that Earth might be such a preserve, a cosmic national park where we are the unwitting inhabitants, going about our lives unaware of the watchful eyes that observe us from the shadows. Perhaps they are studying us, learning about our culture, our history, and our potential. Or perhaps they are simply content to watch us from afar, marveling at the diversity and resilience of life in all its forms. And finally, the interstellar travel challenges theory. The immense distances and energy requirements for interstellar travel might make it impractical or impossible for civilizations to explore or colonize other star systems effectively. Even if they exist, they might simply be too far away. The vastness of space is difficult to comprehend. Even traveling at the speed of light, it would take years to reach the nearest stars, and thousands of years to cross the Milky Way. The energy requirements for such journeys would be astronomical, and the challenges of sustaining life in the harsh environment of interstellar space are immense. The interstellar travel challenges theory suggests that these obstacles might simply be too great, even for the most advanced civilizations. Perhaps they have explored their local neighborhood, but the cost and difficulty of venturing further afield have proven to be insurmountable. And there you have it. 10 fascinating theories that attempt to explain the Fermi paradox. Each one offers a unique perspective on why we haven't yet found signs of extraterrestrial life, from the challenges of interstellar travel to the possibility that advanced civilizations choose to remain hidden. The Fermi paradox is a reminder of the vastness of our universe and the mysteries it still holds. It challenges us to confront our place in the cosmos, to question our assumptions about the nature of life and intelligence, and to keep searching for answers to some of the most profound questions we can ask. What do you think? Which theory resonates with you the most? Let us know in the comments below. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more cosmic content. Thanks for watching, and until next time, keep looking up.